Hello, math students. Mr. B here. All right, we're going to have a quick review of fractions. I'm going to have 3 videos for this, and hopefully this will refresh your memory. I know you've all seen fractions before, but you might need a quick review. So, what is the meaning of a number like 3/4, 3/4? This number on the bottom, we call the denominator, right? Denominator tells you how many pieces you divide 1 into. So, number of pieces 1 is divided into. So we might use a pizza pie or something, a pumpkin pie, to show that. Here's a pie divided into 4 equal pieces. Or we could use a number line representation. So starting at 0 up to 1, and we're going to divide this line segment here into 4 equal pieces. All right, what's the top number? The top number, you might remember, is called the numerator. Numerator. And it tells you the number of pieces you actually have. Number of pieces you have. In this case, 3. And let's illustrate using our pie or number line what 3/4 is. So 3 of the slices of pie, that's 3/4 of a pie, or we would shade 3 of those pieces on the number line. So this is 3/4. This is the location 3/4 on the number line. If you take 3 and divide by 4 on a calculator, you might find you get 0.75. That's the decimal representation of this position on the number line. 0.75 and 3/4 are equal to each other. All right, let's talk about some terminology here. So when the numerator is less than the denominator, they call this a proper fraction. Proper fraction. And here the numerator is 3, which is less than 4, right? A proper fraction is a fraction where the fraction is less than 1. So 3/4 as a number is less than 1. And you can see from our pictures that the shaded region is less than 1, right? It's less than a whole pie, and the shaded part of the number line is less than 1 long. All right. So if this is example 1 here, let's do example 2 where the number is 5/3 or 5/3. So now we're taking our pie and dividing it into 3 equal pieces, right? And the numerator is 5, and we can see, wow, we've only got 3 here. We need a couple more. Let's create another pie, divide that into 3 equal pieces, and now we can shade the 5 pieces that are 1/3 big. So 3 pieces from the first pie, that's 3 of the thirds, and then 2 more makes the 5/3. We can see that the number we have is actually 1 2/3. But this video is not about mixed numbers, but that's what it is. 1 2/3. That's what 5/3 is. Or we could use a number line here. Let's see what a number line representation would look like. Here we need a piece of number line that's more than 1. There's 1, there's 2, and we're going to divide each unit length here into 3 equal pieces. And we want to shade 5 of those equal pieces. So 1 2 3 4 5. There we go. So here's 5/3 on the number line. How about the terminology? This is called an improper fraction. Improper fraction. Improper fractions, the numerator is greater than or equal to the denominator. So certainly 5 is greater than or equal to 3. An improper fraction means that the fraction is bigger than or equal to 1, which is what we got here, 1 2/3, right? That's bigger than 1. If the numerator equals the denominator, you get 1, right? 5/5 would be 1, or 3/3 would be 1, 8/8 is 1, right? So the fraction would be equal to 1 when they're equal to each other. All right, let's move on to the next topic here in this video, which is going to be about multiplying fractions. Multiplying. So to multiply fractions, let's say we've got a over b times c over d, just some abstract fractions. The a, b, c, and d are numbers. Well, you don't need a common denominator or anything like that. You just multiply straight across. You multiply the numerators, a times c, you multiply the denominators, b times d, and that's the result. So let's say we have the numbers 3/7 3/7 times 2/5. Well, we're going to multiply the numerators, we're going to multiply the denominators, and get 6/35. Okay, how about dividing? Dividing fractions. So generically, if you have a over b divided by c over d, what do? You may remember that you leave the first fraction alone and you switch to multiplication of the reciprocal of the second fraction. So this is the flip. You flip the fraction over. So c over d, its reciprocal is this d over c. And now that it's multiplication, you do what we just did before. You multiply the numerators, you multiply the denominators. So you get a over d, a times d over b times c. Let's do a quick example of this. Let's say we have 2/3 divided by 5/7. That's going to become 2/3 times the reciprocal of 5/7 is 7/5, 7/5. Then we multiply the numerators, 2 times 7. We multiply the denominators, 3 times 5. And our end result is 14/15. All right, the last topic of this video is going to be simplification. Simplification. Sometimes people say reduce the fraction. Reducing the fraction. So let's start with 12/18. Now we could take a pie and slice it into 18 pieces and keep 12 of them. But there might be a more simple way of describing how much of the pie we have. So here are the steps to do that. This is one way to do it. There's several ways to do it. This is maybe the easiest way to see what's going on. Who remembers what a prime number is? A prime number is a number that's only divisible by itself, can be divided by itself and 1, excluding the number 1. We don't include 1 here. So those are numbers like 2 and 3 and 5 and 7 and 11. I'll quit there. Right? These numbers are only divisible by themselves, divided by themselves, can only be divided by themselves or 1. And then we're going to do something called making a factor tree. Factor tree. If we take 12, I like to do this systematically, starting with the smallest prime number that divides into the number. So 2 goes into 12 because 12 is even. 2 goes into 12 6 times. 12 divided by 2 is 6. You can see if you're correct by multiplying these two branches together. 2 times 6 is 12, the number above. All right, 6 is still even, so 2 goes in, 3, and then 3 goes into itself once. I'm using the prime numbers on this left side, right? Nothing but primes. So when you get to 1 on the right, you're done. And 12, its prime factors that multiply to 12 are 2 times 2 times 3. If we do 18, 2 goes in 9, 3 goes into 9, 3, and then 3 goes into itself once. So here are the prime factors for 18. Some people call these prime factorizations of the number. So, all right, now I'm going to use multiplication kind of in reverse. I'm going to unmultiply these. I'm going to say, okay, this is 2 over 2 times 2 over 3 times 3 over 3. And notice that 2 over 2 is 1. 2/3 is 2/3. 3 over 3 is 1. And 1 times anything is itself, so these 1's kind of just go away, and we're left with 2/3. So 12/18 is the same thing as 2/3. That's the simplest way to say 12/18. You could circle the things that are common top and bottom, right? Those are the ones that turn into 1s. Some people just cross these numbers in the circles out and say, oh, they cancel, right? Leaving the 2/3. That 2 times the 3, though, right? Those are the numbers in the circles. That equals a special number, it's 6 here, called the greatest common factor. Greatest common factor. We'll use greatest common factors later in algebra. But anyway, some people abbreviate this GCF, right? Notice that 12 over 18 could be written as 6 times 2 for 12, and then 6 times 3 for 18. And then, using the same idea I used before, 6 over 6 times 2 over 3. But 6 over 6 is 1, so we really get 2/3 again. So, using the greatest common factor, you can reduce a fraction like instantly with one shot. Or, as you can see, you could break up the numerator into its prime factors, break up the denominator into its prime factors, and maybe cross out the ones you have the same thing on top and bottom, right? You cancel to get the 2/3. Or you can just look at the fraction and go, oh, 2 goes into 12 6 times, 2 goes into 18 9 times, and then, oh, I see 3 goes into 6 twice, and 3 goes into 9 3, and there's the 2/3 sitting there. So take your choice. All right, folks, that's it for this video. We'll see you in the next one.